This video is going to help you with 8.4 and 8.5 extends. So what you see first is that we have a combination circuit on the left-hand side here. What I've done is shown you that we've kind of simplified this circuit as we go and how I've added them together to find a total resistance. Our ultimate goal is to fill in a table for this combination circuit by using the rules that we know apply to both parallel and series circuits. So to start, if we take a look at the circuit that's on the left here, I have a 6-volt battery. First and foremost, I can fill that into my total voltage, 6 volts. I can also take a look and see that I have 1, 2, 3, 4 different resistors and they're numbered. So what I'm going to do is just put those into my table right away. R1 is 1 ohm, R2 is 3 ohms, R3 is 2 ohms, and R4 is 4 ohms. My goal is now to figure out what that total is and fill in the rest of my table along the way. What I've done here is I see that R3 and R4 are in parallel to each other. So when things are in parallel, remember that we add them up, 1 over 2 plus 1 over 4. What that also looks like is 2 over 4 plus 1 over 4, which is 3 over 4. My next step is to remember that I flip these and I get 4 over 3. If I divide that out, I end up getting 1.33. So the number I'm going to put in right here for my R24, right? Or I'm sorry, R34, added together is 1.33 ohms. My next step is to just add this 1, this 3, and this 1.33 since they're all in series. So that's why I have over here R1, 2, 3, 4. It means I've added them all together. I end up getting for a total here 5.3 ohms. So before you saw me erase a couple of things, I had a mistake on there. So follow what I have on the screen right now. Now that I have that total, I'm going to put it into my R total column. So R total, 5.3 ohms. All right, so my next step here is to figure out what can I solve. Anytime I have only one variable missing out of an entire row, I know that I can use Ohm's law. Remember that Ohm's law is I is equal to V over R. If I want to solve for I take my volts, 6 volts, divided by my resistance, 5.3 ohms. If I divide that, I get a total current. In this case, it's 1.13 amps. 1.13 amps. Now it comes to remembering some rules. If you think about the currents in a series circuit, it stays the same all the way through, right? One path, one current. If we take a look at what we have going on here, R1 and R2 are in series to the battery. And so what that means is that these two resistors are going to have the same current as our total current, right? So as our current flows, it stays 1.13 amps. Right, until it needs to branch. So for resistor 1 and resistor 2, I'm going to put in a total of 1.13 as well. So 1.13 amps, 1.13 amps. That allows us to then solve for voltage. If we're going to rearrange Ohm's law here, and I multiply each side by R, I end up getting Ri equals V. So to solve for this voltage, I take the resistance times the current. For our first voltage drop, we get 1.13 volts. For our second, we get 3.39 volts. I'm going to draw these in on your circuit in green here. So resistor 1 uses 1.13 volts. Resistor 2 uses 3.39 volts. So what we're doing here is we've calculated some voltage drops. This number is saying of the 6 volts that enter the circuit, this resistor uses 1.13 of them. This resistor uses 3.39 of them. We need to figure out what's left when it goes into this area that branches. So we'll take our total 6 volts, we'll subtract what resistor 1 uses, 1.13 volts, and we'll subtract what resistor 2 uses, 3.39 volts. When we subtract that, we get 1.48 volts left. What this means is that this part of the circuit resistor 3 or resistor 4, depending on the way the current goes, get to use that much voltage. So our current leaves the 6-volt battery, it goes through resistor 1, it goes through resistor 2. Now it has two options. It can go left or it can go right. What this means is that these are in parallel. This current needs to split up and go either right or either left. Another thing about this area of the circuit that we can look at is, again, back to the voltage. In a parallel circuit, the voltage gets used in whole. And so what I mean by that is that if what's left here is 1.48, this resistor uses 1.48 volts, and this side uses 1.48 volts. Because there's only one resistor on one side, we know that both 4 and 3 use that total amount. Because remember, if what's left coming into this place is a total of 1.48 volts, any of the resistors that are left use all of it. And so what I mean by that is that if the current leaves the battery, goes through 1, goes through 2, and goes through 3, all of the voltage needs to be used. That means that 1.3, 3.39, and 1.48 should add together to give you your total voltage. So I'm going to put this 1.48 volts in for the voltage of 3 and 4. Because they're in parallel, they get to use all that's left of the battery. So over here on the voltage side, I can put 1.48 volts. What this allows us to do is then calculate our current using I is equal to V over R. Remember, we said that that's Ohm's law. So if I take V, 1.48, divided by 2, I should get my current at the third resistor. I should get 0.74. If I do the same thing for the fourth resistor, 1.48 divided by 4, I should get 0.37 amps. Now I can take a look, my table is totally filled in. Let's address what each of these numbers means. Our 1, 2, 3, and 4 are the resistors within our circuit. We found our total by simplifying the circuit to one resistor and adding with the rules of series and parallel. We found current and voltage by remembering that if things are in series, they keep the same current. If things are in voltage, they keep the same volts. Remember that over here, V1, 2, 3, and 4, these are the voltage drops. If we think back to what we talked about with voltage drops, that's the amount of the battery used by that resistor. So the voltage drop 1 means that resistor 1 uses 1.13 volts. Voltage drop 2 uses 3.39 volts. Voltage drop 3 means that resistor 3 uses 1.48 volts. Voltage drop 4 means resistor 4 uses 1.48 volts. Now again, if you're looking at them thinking those voltages don't add up to 6, depending on the path that you take, they do. So if you take the path and you go through 1, through 2, and your current decides to go through 3 and goes back to the battery, these 3 numbers are going to add up to 6. If your current takes a different route and you leave the battery and now you go through resistor 4 and back to the battery, resistor 1, 2, and 4 are going to add up to 6. So again, it's all about the path that the current's taking, how much battery is it using, and what is the value of resistance that it's going through.